大家回到我们的论坛 ，Ladies and gentlemen, welcome back。接下来呢，我们要进入 ISP 发展特别兴趣小组的场次，主题是智慧网络赋能永续转型，台湾 ISP 产业新局。We now proceed to the ISP Development Special Interest Group titled Intelligence Empowered Sustainable Transformation, a New Era for Taiwan's ISP Industry。这个场次呢，将聚焦在次世代通讯的时代之下，台湾的 ISP 产业在数位转型还有近邻转型上面的挑战。我们会讨论在 AI 自动化维运应该如何协助机房还有基地台节能减碳，并且思考低轨卫星还有异质整合部署之下，如何兼顾网络的韧性还有电力的消耗。In this session, we're going to focus on the challenges facing Taiwan's ISP industry in digital resilience and net zero transition in the era of next generation communications. We will explore how AI for IT operations can help data centers and base stations save energy and reduce carbon emissions, while considering how to balance network resilience and power consumption in the deployment of low Earth orbit satellites and heterogeneous networks。这个场次的主持人是台湾网络维运社群王燕杰主席。The moderator for this session is Mr. 燕杰王 Chair of TWNIC。接下来就把时间交给主持人王燕杰主席，有请。
Colleagues, ladies and gentlemen, good morning. My name is Yanjie Wang, Chair of the TWNIC. First of all, we feel truly grateful for the opportunity to speak at Internet Week 2026. And in this session, we will be talking about how to leverage technology to reduce emissions and build resilience. Now, first, a few words about using technology to reduce emissions. You know that the key to cutting emissions is to have a comprehensive inventory of your Scope 1, 2, 3 emissions. Scope 3 emissions in particular actually take up the largest share among companies because it encompasses the entire supply chain. For example, for your procurement, and you need to have good understanding of the emission reduction across your supply chain. Now, the second issue, digital resilience, is also a trending buzzword this year, thanks to the rise in satellite technologies. So we need to have comprehensive redundancy design with these emerging technologies. So we have some introduction of wireless connectivity and satellite next-gen communication or dedicated 5G connectivity among the potential options. So with these technologies serving as the base technology, we still have to consider how to go about cutting our emissions. So that's why we are here today, joined by 4 distinguished panelists. The first one being the Technical Director, Nigel Chen from Nokia. The second one is Senior Solution Architect Daniel Liu from F5. Third off is Senior System Analyst Shanpei Chen from the Ministry of Education. And last but not least, Least Service Solution Manager Sherry Wang from Ericsson Taiwan. So together, the 4 panelists will deep dive into the topic from the perspective of device, solutions, and others, and also from the perspective of users. So with that, I would like to give the floor to our panelists for a brief self-introduction and your observation on these 2 trending topics. Thank you very much. I'm honored to have the opportunity to speak at Internet Week 2026. My name is Nigel Chen. Currently, I am in charge of the development of wireless connectivity, tech revolution, among others. So I'm mainly responsible for engaging in discussion with our local clients. And in particular, we've been focusing on 5G connectivity. And as for 6G connectivity, we are also in the process of discussing potential solutions with local clients. Thank you very much, Nigel. Now let's welcome Senior Solution Architect Daniel Liu from F5. Hello, everyone. I'm very happy to be invited to speak at this panel. My name is Daniel Liu. I'm in charge of the security architect and analysis in the APAC region. Now, when it comes to ESG, of course, it is a hot topic, and our company has also been paying a lot of attention as part of our corporate DNA. We are trying to incorporate a lot of ESG solutions by integrating them into our framework. We know that our company is a well-known name in the IT sector. So we, of course, have been trying to strike a balance between tech development and emission reduction, and I'm looking forward to sharing our insights. Now, Senior System Analyst Pei from the Ministry of Education. Hello, everyone. My name is Shan Chen Pei from the Ministry of Education, or the MOE. I'm very happy to be here and share with you our efforts on within academia in Taiwan. So we have this Taiwan network of academia. So basically, the network serves all levels of education institutions in Taiwan. So it provides resources on teaching, research to all the faculty members, teachers, and students for the past 30 years. Of course, we witnessed developments in technology and management principles. In particular, from 2017, Taiwan has been promoting the forward-looking infrastructure plan, and later we have the outbreak of the COVID-19 pandemic, and now we actually popularized the use of tablets so that every and each students in Taiwan can have access to tablet as a learning tool. So we also try to popularize the results of research in primary and secondary education. Of course, challenges emerge along the way. That's why recently we have an upgrade plan. We have this backbone bandwidth upgrade from 100G to 400G in order to enhance digital resilience. Also, in response to AI developments, we have introduced measures to increase efficiency. For example, CDN and network management. So also an initiative called TANET. So later we're going to share with you how ISPs can respond to challenges of AI and digital resilience. Thank you. Last but not least, let's hear from Lead Service Solution Manager Sherry Wang from Ericsson Taiwan. Hello, everyone. I'm in charge of solutions in Taiwan for Ericsson. So basically, we're trying to introduce global AI solutions to Taiwan. So in terms of 5G and energy savings, we've been using relevant technologies for 2 years. And on average, we have already helped Taiwan reduce about 5 to 7 million kilowatt hours of energy for Taiwan every year. So that's the self-introduction of our 4 distinguished panelists who will be addressing the 2 topics I just mentioned. Personally, speaking on behalf of TWNIC or the ICT industry or ISPs, traditionally, when we went about managing the internet, we relied on experience and human input. So, but recently, with the advent of newer generations of AI, which has given rise to economic growth, people have been thinking about how we can introduce AI into operations. Hence the concept of AI ops. We know that different ISPs or vendors have come up with a variety of solutions, be it Nokia, Ericsson, or other device vendors, have one after another introduced AI modules in their operations. So these AI-enabled modules have been, I should say, tested, not comprehensively implemented, but many of them have been put to pilot tests in Taiwan. And we know that technically, or technology-wise, we do have some emerging solutions available. So how can we connect these solutions to automation and energy reduction? Now, AI ops have two major implications to vendors or providers. That is the stability of network, or service sustainability. So we don't want a situation where the introduction of new technology will lead to faulty decision making and the crash of the network. That is indeed totally unacceptable by users and ISPs alike. So given that premise, we have also to reduce our emissions. So we have to strike a balance between energy efficiency and operational efficiency. So I will now first give the floor to Mr. Nigel Chen from Nokia Solutions. Can we actually do a better job with our current experiences in 5G? Thank you, Chair Wang. Yes, you made a good point in saying that based on the GSMA data, for an ISP or network operator, 60 to 80% of network energy consumption comes from wireless communication. So that's why many of us have outlined a clear ESG goals. So as we know, 100 of us, including Zhonghua Telecom, have already announced their ESG ambitions. For example, by 2040 or 2050, many of us aim to reach net zero emissions by then. If we want to get us there, first we have to reduce the largest share of our energy use, that is from wireless communication. We can think of a variety of solutions. Take Nokia, for example. We have crystal clear ESG targets that have already been announced. For example, by 2040, we want to achieve our net zero milestone. But by 2030, we want to reduce our scope 1, 2, 3 emissions by 50%. And scope 1 and scope 2 emissions need to go down by 99% even by 2030. So as we move towards our targets, we need to consider how we can better deploy our cash or software, hardware, or AI. In terms of hardware, we always have new generations of products coming out once every few years using new chips. So these new generations of chips can help us achieve 50% better performance in energy efficiency. And also we have a comprehensive software architecture to help us cut emissions from base stations. In terms of software, we have this shell shutdown mechanism that is, for example, during the evenings when loading is low, we can switch off some of the base stations. But before switch off, we need to transfer the communication from certain users to other base stations in order not to interrupt or undermine our network coverage or user experience. We also have other tools at our disposal. For example, on the era of 5G, we use this kind of basic mobile radio device. So Mission Bible, when running in low loading environment, can actually enable us to switch off certain transceiver. So for example, there's 32 TRS. So in the low loading environment in the evenings, we can reduce the volume from 36 to 12 units. And in terms of hardware, some of the chips can also go into sleep mode or go into extreme deep sleep. That can help us save more than 90% of energy. So we have this two-pronged approach. On one hand, we have comprehensive toolkits to help us reduce energy and emissions. But now, or in the past, we need to rely on human adjustment. We need to actually rely on human input to adjust the parameters manually. For example, when are we going to activate or deactivate the deep sleep mode? We used to rely on manual adjustment.
现在已经通过
Now, we have better tools. I'm talking about AI and LLM. In other words, we don't need to make adjustments manually. Simply by leveraging AI tools and AI algorithms, we will be able to assess, with regard to a specific cell, what is the current traffic and what is the current KPI status, so that the system can come up with a judgment when to turn on or turn down a specific component of the system, so that we can successfully achieve our targets. Therefore, through the leveraging of AI tools, we have been able to maximize the efficiency of the operation of our network. Therefore, we are improving our SIG scores as a result. So, as you have already mentioned, there are 3 key points. First of all, in the beginning, you analyze for your network what time is the peak hours and what time period is off-peak hours. So RF power can be adjusted based on whether the time period is peak hours or off-peak hours. And you do this without compromising service quality. Even if you have turned off some RF components, service quality will not be sacrificed, but you can achieve a lot of energy saving. You also talk about upgrading your chips, and you implemented new technology such as mass MIMO. With the introduction of those new technology, this is where, again, you can achieve even higher energy saving. And number 3, you are using AI tools. AI systems will help you assess for certain hours of a day. For certain hours of the day, you will be able to achieve better energy saving by making sure AI will help you make a judgment which component can be turned down. Obviously, we would like to go to Mr. Daniel Liu of F5. Can you share how you can do a better job of controlling traffic in order to achieve greater energy saving? We know this is Internet Week. When we talk about the Internet, obviously we want to achieve greater energy saving. And according to a lot of surveys, 30% of traffics are actually non-productive traffic. There could be advertisement, there could be malicious attacks. So they will have negative impact on our cost as well as the efficiency of the operation of our network. So we really need to identify better solutions, how we should manage traffic in a better way. In recent years, Cloudflare, Google, they emphasize DOT, DOH. By activating those technologies, we know that typically Internet began to lose its capability to identify different types of traffic. And you have no way of tracing where the traffic will be carried to. Therefore, we often talk about sovereign AI. But before we can achieve sovereign AI, we need to make sure every ISP needs to make sure when traffic comes through our gateways, we will be able to identify different types of traffic. For example, malicious traffic, unnecessary traffic should be deleted. And that's a very important thing, and that's something that can be easily done. So when it comes to maintenance and operation of the system, what we want to do by leveraging AI system is to make sure all the relevant data can be precisely analyzed, and based on the result of the analysis, we can do a better job of managing the traffic. Therefore, if we want to achieve automated traffic management, all of your equipment needs to be supported by API. In other words, we can no longer use traditional equipment that are equipped only UI. We need to make sure there will be API. And smart ACP server is also critical. Once you have those components, then you can build up your automated production environment. You can build up your automated traffic management system. But we should not completely trust AI, because AI sometimes comes up with illusions. Therefore, you need to set up checkpoints. And along the way, you need to do inspection within the degree of control and adjustment you can do. You need to do inspections to make sure AI assessment is not off the mark. Therefore, this is something that needs to be carried out and achieved step by step. This is not something that can be achieved overnight. There's a price to pay for enhancement of security. Along the way, we probably need to use more energy. We probably need to use more resources such as water. For example, in order to enhance security, we need to identify different types of traffic. Some traffic, as mentioned, is launched by malicious users. Therefore, we need to begin with identification, and then we can do a better job of managing traffic. So, filtering, management of different types of traffic, I think that's the first step. So, obviously, we need to make sure security is incorporated into every step of the process. We often say security by design, and that's exactly what we mean. And that's from the very step we think about security. For example, if data set is compromised, then obviously this will give rise to problems in the eventual outcome. You need to pay a price, and you need to find a better trade-off between energy consumption and the end result. So from what you have just shared, I have two key takeaways. First of all, when it comes to traffic management, you talk about the CDN operators. They manage a massive amount of traffic. When traffic runs through certain equipment, eventually delivered to global users. And for equipment to process traffic, obviously energy consumption is required. Therefore, you don't want traffic to run rampant. For example, illegal traffic, malicious traffic should be stopped at the equipment without being passed along to other part of the network. So if you can do that, then the majority of service providers will be able to achieve energy saving. And you also leverage AI to help assess what traffic is unnecessary, what traffic is launched by malicious actors, and what traffic should be stopped at the door. So thank you very much for sharing your experience. When it comes to application of AI and managing the traffic of CDN, we know that now at your system, you are deploying CDN in your network. So can you share with us what have you learned in that process? Well, we are responsible for managing the academic network of Taiwan. Our mission is to provide teachers and students high-quality internet services. The type of services that can support both teachers who will be doing their teaching jobs and students who will be doing the studying by using the internet. I think our main responsibility, instead of achieving energy saving, people's expectation for our network is to provide a high-quality network that can support the educational community. We have set up edge servers, and by utilizing DNS traffic management, therefore, what we want to achieve is that locally at different cities and counties of Taiwan, when they receive the information through our network, for example, at the classroom, then because the content has been caught at the edge server, therefore, they don't need to go to the core data center for the content they need. This can be more efficient. And CNC or blacklisting, these are tools where we can use in order to filter out bad actors, in order to improve the security. And also, we need to protect children and young people. In other words, if there are any toxic or harmful content, they should be filtered at the first stop. Therefore, our network is designed to service the needs of primary and high school students. Therefore, we need to make sure we do a better job of traffic management, including filtering out harmful content. So this is where we use CDN to improve efficiency. As mentioned by other panelists, we are academic in nature. We have massive architecture because we are serving a huge population. For a school-based PC to be connected to a website in order to access certain services, first of all, we need to go through many steps. First of all, the school network needs to be good. And then the backbone network also needs to be robust. And the backbone network needs to get connected with the global infrastructure. Therefore, there are many things that we need to look at. And obviously, school networks, I'm talking about primary schools, middle schools, they don't really have dedicated IT personnel. Therefore, beginning with the forward-looking infrastructure project that was implemented in 2017. We tried to make amends, and we begin with visibility of our network. In other words, we will be able to easily identify the pain points, locations where there are problems in the network. Especially now in this day and age, AI agents are being considered to be deployed in the network in order to help identify the problems. Again, this can help reduce the burden for the teachers, given the fact that the traffic through our academic network, probably 50% or more, are coming from primary schools and middle schools. So by implementing smart traffic management, not only we want to leverage AI to make our network greener, but also achieve greater energy savings.
Thank you very much for your contribution. So we will now hear from our manager from Ericsson, Ms. Sherry Wang, to share with us how Ericsson break through its energy bottleneck. And we also have one participant queuing up in front of the mic rack. So please kindly wait a few moments as we wrap up the first round of interventions. Yes, thank you, Chair Wang. You talk about how we can break through the energy curve bottleneck as ISPs. Ericsson is using AI and machine learning capabilities in that area. Why is that? Because we have this interim tier 4 target. Usually there are 6 levels. Level 0, 1, 2 means zero introduction of AI, and level 3 to 5 means you have introduction of AI. So ultimately, we want to achieve autonomous network that runs itself without human intervention, so that all networks are operated in a closed loop. And in terms of 5G, not only have we focused on hardware, we also leverage automated management. For example, during off-peak hours, we not only look at one single cell, but also the overlapping areas between 4G and 5G, and also where the crowd is going. So let's say if the crowd is moving towards a certain cell, we have to activate that cell without compromising user experience. We also respond to emergencies. For example, earthquake alerts, an emergency message which you cannot afford to miss. So with the use of regional-based cross-type management, we're able to enhance our efficiency. Not only can we reduce energy consumption, ISPs can also see their revenue grow and energy consumption decline. So that's why we are able to save 5 to 7 million kilowatt hours of energy per year on average. Well, you just mentioned how you help operators strike a balance between cost considerations and energy efficiency. You achieved gains from the two fronts. But my question is really because you are running an autonomous closed loop network. That is, in normal times, you don't need human intervention. And the network can autonomously predict where and when operation and maintenance are needed. So can you say a few words about predictive maintenance? What kind of things is the system predicting, and what kind of tasks can be done to help ISP reduce millions kilowatt hours of energy? Well, every day we collect the traffic data from all the cells around the clock. And according to our data, we actually retain the records for 6 months. and use them to train our machine. So each cell will have its own specific ways of modeling. It's not that we only have one model for all the cells. If that's the case, we cannot effectively predict how the cell is going to respond to emergency, because the cell may be deployed in a department store or residential area. So that's why we have to receive the latest traffic data from all the cells 24/7 for simulation, so that we can predict what's going to happen in the next 24 hours. That's the way we monitor cells. And we also have a business logic. That is, we can also monitor or predict what's going on in the adjacent areas. For example, around the cell, there may be 12 or 24 tier 1 coverage points. So we can also monitor the neighboring or adjacent areas to see if there's overloading taking place. If that's the case, then the target cell, which is on energy saving mode, will be activated. Because we know that crowds move in different directions. So behavioral pattern will also be used for system simulation. And after running the project for 2 years with repeated learning and model optimization, our accuracy can now hit 90 to 93%. We also do regression analysis. So that's our current solution. Thank you, Manager Wang. So yes, crowds data are very important because people are toting their smartphones, their devices. You know where people are going. So you need to have a good grasp of the crowd's movement in order to enable predictive capabilities. So we do have some questions from the floor, please. My name is Guowei Wu, currently the chairperson of TWIGF. I was a deputy director of Taiwan's High-Speed Computing Center and also an independent director of Zhonghua Telecom. So I have a few questions for our 4 panelists. Let's brainstorm regarding how we can solve some of our current challenges. First, I think both Nokia and Ericsson know that Taiwan's 5G projects are not really considered really successful because a lot of people are running their device on 4G. So for ISPs like Taiwan Mobile or Zhonghua Telecom, the cost barrier is still very high for 5G development, and a lot of people are still reluctant to migrate from 4G to 5G. You have to think about recovery of legacy devices, or you need to think about the return on investment. So cost barrier is still a major barrier. 4G is still relatively cheaper, and the bandwidth gap between 4G and 5G is not as big as expected. So that's my first observation. Now, the second question is about TANET, or Taiwan Academic Network. So in the old days, all the operations of TANET was run by a technical and governance committee. Usually the members of the committee are directors of IT centers of universities in Taiwan. And the technical committee is run by technical engineers. But we observed several problems. First, is there anyone who is still thinking seriously about the development of TANET, or Taiwan Academic Network? Second, TANET is now no longer considered an important ISP, because take a look at the backbone compared to the larger giants like Far Eastern or Chunghwa Telecom. There's a huge difference between backbone capacity and traffic volume. It just cannot compare with the largest 3 telecom giants in Taiwan. But TANET actually still think highly of itself, and for example, let's say Zhonghua Telecom or any ISP would like to compare or do peeling with TANET. TANET usually holds a very conservative attitude. So, for example, a lot of ISPs are based in central or southern Taiwan, but TANET always think that such process should take place in northern Taiwan, leading to waste of network resources. So I think TANET should really seriously think about how it can reasonably engage in reasonable peeling in an open manner with major ISPs, because you are no longer the market leader or number one as in 20 years ago. So TANET should stay open-minded to engage in peering. Peering. The same is true for peering with ICPs. So it's very difficult for these tech giants like Google or Facebook to engage in peering with you, but you are not that important as you were 20 years ago. You enjoyed huge traffic, but that's not the case anymore. And now, all students and teachers are also using telecommunication services by the top 3. And people sometimes think that TANET is not very user-friendly, so why not switch to ready-made solutions from top 3 providers? So that's some of the challenges you have to think about as TANET transform from a public into a private entity. Otherwise, all the dollars that have been put into TANET will go down the drain from the perspective of backbone capacity or international standards. TANET only takes up about 1 or 2% of total volume. So that's also a hassle for major ISPs, because all ISPs and ICPs can actually help TANET do a better job, because they have a wider coverage. So all the mobile operators now boast more extensive coverage, for example, into far-flung or remote rural areas. So I think if TANET really wants to improve, you can think about how you engage with other ISPs and really identify your position. Otherwise, I see a lot of resources are wasted.
Thank you very much, Chairman Wu. You proposed 2 major recommendations. First of all, for Ericsson and Nokia, you recommended that through making investment, we should try to enhance the speed, enhance the quality, in order to make sure we can successfully transition to 5G. So I don't know whether you would like to respond to the recommendation by Chairman Wu. I'm looking to our friend from Nokia and Ericsson. Hopefully you can respond to his recommendation. Well, in terms of academic network, this is not a commercial network. Obviously, the purpose of academic network is to make sure academic data can be transmitted across different schools in a very secure and stable way. And obviously, we have Goffin with us, and I'm sure Goffin can probably say something about this, how we can improve academic network. So I would like to go to Nokia first. I think that's a very good question, because right now, the reality we are facing is that we haven't seen enough growth in 5G adoption, because the majority of the users are still preferring 4G. Why? Why do we want to promote 5G or even 6G? So obviously, this is something for all telecom company to think about. When it comes to 5G, obviously we need to understand the user's behavior. They need to get on to the internet. They want to watch videos. They probably don't need 5G. However, nowadays we see a lot of people, they are binge watching a lot of movies and videos, even riding on the car or on the train. But when they do that, then obviously traffic is much bigger. Therefore, there's a need to move up to the 5G. For telecom companies, we need to find good ways to monetize 5G. And we need to transform users' behaviors into new business model for the company. For example, dedicated line for big corporations or other real-life applications. For example, overseas, let's use T-Mobile US as an example, because they are a very good success story when it comes to promotion of 5G. They manage their networks extremely well. For example, within their network, they have already produced 30 network slices. In other words, based on different needs, based on different user groups, they are able to provide targeted services. So each slice is for a precisely targeted customer group. It could be government, it could be schools, or it could be corporate dedicated networks. And that's what they do. They are able to provide targeted services through slicing up their networks. Therefore, probably that's what we can try and do here in Taiwan as well. We need to have a strategy to provide more granular services, custom-made services for different user groups. And so as a telecom company, the most important thing is to more efficiently maximize our revenue by providing better services. You talk about the network slice and then map network slices to customer needs. So based on the needs of different customers, for example, if it's firefighter community, if it's policemen, what they need is quicker response network services. However, with regard to general public, they do not have to deal with emergency situations, then we probably can use another network slice to service their need. Indeed, that's what I was talking about. What about Ericsson? What's your view on this particular question? I would like to thank our Mr. Wang for the question. Well, for our company, Ericsson, when it comes to 5G deployment, we hope that we can maximize revenue coming from 5G. Network slicing had been mentioned. And for our company, let me give you an example. If you are a marathon runner, you will be given this type of service based on network slicing. So while you run your marathon, all throughout, you will not experience disruption of services, or if you attend a concert, then again, the concert goers could be looked upon as a specific user group. And in Singapore, well, our slogan is you can enjoy first-class services while surfing our network, just like you could be a first-class passenger on an airplane. If you want to watch video, you want to binge watch TV programs, and you want to make sure service will not be disrupted, because you are first-class passenger, right? So for the type of users, they can apply for 5G services. In other words, I'm talking about differentiation of different services. And for example, concerts, marathons, sports event, or even for F1 Grand Prix. These are specific user groups, and they can enjoy 5G services much more. Obviously, we are talking about different application fields. For example, you talk about event-specific service level, so that you talk about examples where users will experience 5G services more. I would like to go to golf, and in the interest of time, I hope you can be quick because we need to move on to the next agenda item. I would like to thank Chairman Wu. You are obviously a well-recognized pioneer of network development in Taiwan, and your question reflects all your concern about the academic network in Taiwan. Obviously, we have a management committee. We have a technical team. We will also consult experts to discuss these very important issues. Obviously, we would want to invite Chairman Wu to join us in our discussions. You talk about peering. Well, this is probably something that is new because previously in our meetings, we talk about the fact that we get connected to local networks through terrestrial cables, but we get connected to international networks through undersea cables. And we do have a project trying to promote that type of connection. TPI's points in Taiwan, we actually are working with local service providers to come in, and so that we can achieve peering between academic network and other networks. However, we do have an exchange center at our National Academic Network Center, and we are trying to build more locations throughout Taiwan where we can enable connection with other networks. For example, GSN is an example where it's even more difficult to achieve peering with other networks. I do believe, because this is an academic network, so we need to make sure we have a designated point where we can create a connection point where academic network can be paired with other networks. If we do not do that, then if we do connection at any point through other network, then the quality, the stability of the entire network could be compromised. Other network providers, we actually been very proactive trying to work with them. It's not what you said, people make a request to get connected to our network, but we say no, that's not the case, because we are more than willing to work with private sector players, but because we belong to the government, therefore when we do anything with the private sector at all, we need to go through government mandated tendering process in order to encourage primary school, middle school teachers and students to use our network. Well, because we want to do this to make sure no students will be left behind. In other words, there's a lot of money to make. And that's why that explains why there seems to be a lack of interest by private sector players to buy equipment. This requires money. If we want to improve the resilience of TaiNet, or if we want to reduce carbon emission, we want to reduce energy consumption, obviously there seems to be a conflict. And if we want to improve resilience, obviously you need to be willing to spend money to procure more equipment in order to make sure you can set up more nodes to make your network more distributed, and there needs to be more redundant equipment. And obviously, once you turn on those equipment, then more energy will be consumed. So there seems to be a conflict here, right? So again, this is a question I would like to put to our 4 panelists. Can you share with us your views? Probably in 1 minute, because we are terribly running out of time. Well, D2D is a very good concept, and it's quite relevant because we are talking about LEO satellites. Because in one of the recent OCRA report, NTN traffic has increased by 25% in the first half of 2026. Half of the traffic comes from the U.S., and people are expecting more growth going forward. TNT D2D will be utilizing LEO satellite to complement terrestrial network. In other words, by combining terrestrial network and LEO satellites, then we believe this will go a long way toward improving resilience. T-Mobile US recently had come up with a new service, T-Broadband. T-Broadband as a package is combining terrestrial network and TNT in order to provide services in areas that hasn't been covered before. So this will become a seamless, comprehensive network. In other words, NTN can be used as a component of redundancy program in order to make sure there will be no disruption in service coverage. What about green traffic? How can we achieve the target of improving the efficiency and resilience of the network, but do not consume too much power? For F5, all malicious traffic obviously is not green traffic. Therefore, obviously, when it comes to product design, you probably know that for a lot of devices, their CPU is not very efficient. So we can use LPGA or RISC technology or DPU. DPU is an NVIDIA technology. These technologies can be incorporated into your platform to increase performance, especially to maximize performance per watt. So if we can increase performance per watt, then we can be more energy efficient. I think this is something that's very, very critical because going forward, all secured devices, if they require login, and when they do login, then obviously energy will be consumed as well. So in the future, more passwords will be quantum type of passwords. So we really need to pay attention to every aspect of product design. So this is where we can leverage a lot of different product technology to improve energy efficiency. Safety is still at the core. And as much as possible, we need to convert non-green traffic to green energy so that we can achieve greater energy saving. But we also need to improve resilience of our network. I also support hybrid cloud, DNS, as well as a whole variety of technologies can be leveraged to not only create hybrid cloud, but also improve the resilience of the hybrid cloud. Thank you.
Thank you. So with that in mind, I would like to give a floor once again to TWNIC representative with regards to your resilience considerations, because now probably you haven't been able to introduce a dedicated 5G network, but have you thought about routing diversification or satellite technologies so that you can beef up your redundancy? So could you just very briefly share with us? We know that the traffic and backbone now has been upgraded to 400G recent years. So, but what if we don't have sufficient redundancy? How are we going to deal with that? Well, take TWNIC, for example, the redundancy for the physical layer, as you rightly mentioned. For example, we face the severance of or a disruption to undersea cable. We did activate redundancy plans of satellite technology, but we were bound by funding shortages. So we still had to rely on Chunghwa Telecom by using microwave technology. So now satellite resources are more expensive, so they will mostly go to educational scenarios, for example, by transmitting critical information, which can be transmitted via satellite. But for large volume transmission of multimedia content, we can use other affordable means. As for 400G, we cannot have heterogeneous redundancy, but as we upgrade from 100 to 400 GT, we have ODM layer and BGP layer, and in between, we can have a segment routing layer in between, so that we can have more flexibility in routing to optimize our downtime and system resiliency. Now, for Ericsson, I think you mentioned the application of network slicing to support, for example, marathon contests or concerts. But how can you leverage AI ops to manage or to enable predictive maintenance while considering network resilience? Let's say I'm a marathon runner or I'm an event organizer, and I hope to leverage multiple network slices for redundancy. But we also have autonomous traffic control, for example, how we letting us know how we can switch from slice A and slice B when needed. Any experience? Yes, this is one of our latest technology called EIAP, Ericsson Network Intelligence Platform. So the platform helps manage the volume in 5G network slicing, network resilience without undermining the average user experience, while this technology serves to support our VIPs. These benefits cannot come at the expense of the general user's experience. So we use a platform called our app to manage the slicing. So use intelligent AI computing. So beyond that, it also provides agentic AI capabilities. So not only can we have a real-time monitoring of different base stations, performance, slicing, hardware troubles, it also is installed with agentic AI capabilities. And it's very powerful because different AIs can monitor each other, so they know how to switch over. Maybe there's an agent that can help us determine when I should switch from slice A to B or to C. So it's more about the realms of agentic AI. So there's one key takeaway. Resilience and hardware infrastructure or energy consumption are not mutually exclusive. The way you can think about it is that, okay, these are the two goals we want to achieve at the same time. So do we have any tools out there that can help us achieve the two goals at the same time? For example, do we have a maybe AI-enabled tool or model for ISPs to consider or achieve their goals of resilience and energy efficiency? Of course, that requires a lot of decision-making at the technical level and also the available solutions by different ISPs. Well, in the interest of time, we'll actually open the floor for comments and questions. Okay, if not, our panelists will probably stay during lunch, so feel free to approach them for further discussion with our experts. So if there's no question or comments, let's bring an end. That's the end of our panel discussion. Thank you.
这个场次最后邀请我们所有的语坛讲者主持人来一张合照，谢谢，非常感谢这个场次的语坛人非常精彩的分享，请大家起身，稍微往中间靠拢一点，来看向我们中间的摄影师。To wrap up the session, we want to invite our panelists for a group photo, and thank you to all the panelists for a lively panel. 好，请看向我们中间正中间的摄影师。比个赞，再一张。谢谢，我们再次掌声，谢谢这个场次的主持人，还有语坛讲者，非常感谢。